Welcome back to Pratik Academy. In this video, we will see Clausius statement for second law of thermodynamics. Clausius statement for second law. Okay. So what is its statement? It states that it is impossible to construct a device working in cycle whose sole purpose is to transfer heat from low temperature to high temperature. So this is the statement. It is impossible to construct a device working in cycle whose sole purpose is to transfer heat from low temperature to high temperature without using any external work. So this is the statement. Okay, so again, as Kelvin Planck statement, it starts with word impossible, so its approach is negative, or we can say this is the negative statement, negative approach statement. Then it is related to device which is transferring heat from low temperature to high temperature. Okay, so it is related to one device which will transfer heat, that is Q, from low temperature to high temperature, low temperature to high temperature. We will see what is this device in later, but at present this law states that it is a device which is transferring a heat from low temperature to high temperature without using any external work. Okay, so for this statement, for this negative approach of law, we will draw one figure. So as per law statement, we require a device. Okay, say this device we will call initially A. Purpose, and it is working between two temperature reservoirs, high temperature and low temperature, and purpose of this device is to transfer heat from low temperature, so let's call it QL, to high temperature. So this is a device which is transferring heat from low temperature to high temperature. Then what is impossible according to statement? It states that it is impossible when we are not supplying any external work. So if work supplied is zero here, then such transfer of heat is impossible according to Clausius statement. Okay, then what is the possible device? Then we can transfer heat from low temperature reservoir to high temperature reservoir with using a device. Initially say it is A. Okay, suppose QL is the heat is transferred from, and QH is the heat transferred to high side, and using some non-zero external work. If W is not equal to 0 or input work is non-zero or positive, then this device is possible. Then what is this device is called? Okay. Then there are two types of devices. One is called refrigerator. Okay. And second one heat pump. Both these two devices are used to transfer heat from low temperature to high temperature. It is TL to TH. QL is the heat removed from low temperature, high temperature, and as per this statement, we require some non-zero positive work to supply. Say it is W, and if we balance here, then W will be equal to QH minus QL according to our first law of thermodynamics. And again here W will be QH minus QL. So this is the refrigerator. Again it is transferring heat from low temperature to high temperature. But when our purpose is to remove heat, desired purpose is to remove heat from body and maintain its temperature low, then it is called as a refrigerator. So in summer condition, surrounding temperature and room temperature is at high condition, and at that point we want to lower the temperature of room. Then what we do, we remove continuously heat from our room and add to surrounding, and due to removing of heat continuously, temperature of room gets lower. So lower side is room here, and we adding continuously heat to environment here. So high temperature side is environment or surrounding, and for maintaining room temperature low and constant temperature, we are continuously removing heat, QL. So this is the refrigerator if purpose is to remove heat. And in second case, what is heat pump? It is similar to our refrigerator, but purpose is different. It will remove from QL heat, QH, then it require W non-zero work, which will be equal to QL minus QH. Then this is the low temperature, high temperature. But this is the heat pump, or when we call this device as heat pump, then desired purpose is to add heat to room. Here desired purpose is QH here. Suppose say in winter condition all are at lower temperatures. Okay, room and surrounding are at lower temperatures. Then we are continuously removing heat from environment and adding to our room, and due to which addition of heat, temperature of room increases and it becomes TH. So here room temperature is at higher temperature and surrounding is at lower temperature. Surrounding, or we can call as the environment, is at lower temperature, and here purpose is to continuously add heat and maintain temperature. So this is the difference between these two. Otherwise all are same, or working is same. Now how to check performance? In case of heat engine, we check performance by defining parameter thermal efficiency. Here we are defining new parameter called as a COP. Okay, what is COP? COP is nothing but coefficient of performance. Okay, COP is nothing but coefficient of performance. It is defined as ratio of desired work upon, sorry, desired purpose upon work supplied. Okay, work supplied. Now apply this definition here we get COP of refrigerator. Here desired purpose is to remove heat from cabin upon work supplied. Okay, remove heat from cabin and work supplied. So here it will comes to heat removing quantity is QL upon work is W, and it will comes to QL upon QH minus QL here. So this is the COP of refrigerator, that is equal to QL upon QH minus QL. Okay. COP of refrigerator. In case of heat pump, here again COP of heat pump, it is equal to, here desired effect is to add this QH amount of heat to room, that is your formula will be purpose is add heat to cabin upon work supplied, and here add heat to cabin is QH upon work supplied is here again QH minus QL, the COP of heat pump. Okay, so devices are same, working is same, but desired purposes are different or exactly opposite to each other. Therefore COP formulas for these two devices are different. And there is one relation, interesting relation between COP of heat pump and COP of refrigerator, is that COP of heat pump is always greater than by 1 of that of COP of heat pump. You can get this relation by simply putting here QH and QL relations. Okay, so in today's video we have seen Clausius statement for second law of thermodynamics. It states that it is impossible to construct a device working in cycle whose sole purpose is to transfer heat from low temperature to high temperature, okay, without using any external work. This is the important. Without using any external work, we cannot transfer heat from low temperature to high temperature. Okay, so again its approach is negative, and the required uh, work is to transfer heat from, or function of device is to transfer heat from low temperature to high temperature. Then if we draw a figure or represent this information pictorially, then we get this type of figure: a device which is transferring heat from low temperature to high temperature, and when work supplied is zero, then this device is not possible. Remember, if is zero work supplied is zero, we cannot transfer heat from low temperature to high temperature. Then what is possible device? Then possible device is we have to supply some non-zero work, and this quantity of non-zero work can be found out by our first law of thermodynamics, that is for steady flow processes, total heat input is equal to total energy input is equal to total energy output. We can, in detail we can see that to heat energy removing from system is QH, entering energy is W plus QL. Here work is supplying, heat is supplied, heat is gone outside, so energy going outside is QH, entering energy is here QL plus W. For steady flow we can write this equation, and from this we get W is equal to QH minus QL. So this is the relation here, W is equal to QH minus QL. So this is the possible one. Then depending upon purposes, there are two devices, refrigerator and heat pump. When we call it is refrigerator, when our desired purpose is to remove heat from our room. We are continuously removing heat here to maintain temperature low. Then COP formula is this: remove heat from cabin upon work supplied, and finally we get QL upon this QH minus QL. And when it is heat pump, then desired purpose is to add heat to cabin so that its temperature will be above surrounding temperature, and relation is COP of heat pump is equal to QH upon QH minus QL. And there is a relation between COP of heat pump and COP of refrigerator. So this is for Clausius statement. Thank you for watching our video. If you like this, please subscribe our channel. Thank you for watching.